Bring it back over to this page. Okay, the last time we began our little unit of graphing, then we looked at the x, y axis and the rectangular coordinate system, and we defined the x-intercept to be a point on the x-axis. And at this point right here, 2, 0. If it's on the x-axis, then that means that you go up or down 0. So we said that on our x-intercept, every y value has to be 0, and it's in the ordered pair x, 0. Same thing for y-intercepts. Y-intercept, point on the y-axis. If it's on the y-axis, then that means you don't move left or right any. So the x-coordinate for the y-intercept is 0. We also looked at the general form for the equation of a line, ax plus by equals c. And we said with a line, there can't be any exponents anywhere in the equation. Okay? No x squared, no x cubes. Okay? And we graphed lines using those intercepts. Plug a 0 in for x, that gets you the y-intercept. Plug a 0 in for y, that gets you the x-intercept. We're going to continue this discussion of lines in more detail. Let me go ahead and make a note. Ax plus by equals c. That's the general form for a line, but I'm going to be more specific. If there's an x and a y in it, then that line is a slanted line. Y'all know what I mean by slanted? Something like that or that. The natural question to ask is, what if there's only an x in the equation, not a y? Well, if you have the equation x equals some number, like x equals 5, x equals 6, that's a vertical line passing through the number c
How do you draw the word through?
passing, did you see that?
Do a little carrot top.
I need a little carrot top here. I left out the word through, passing through. I guess I'm talking faster than I'm writing. X equals C is a vertical line passing through the number C on the x-axis. Now, if you have an equation with only a y and no x, what I'm about to do is rewrite this sentence that I have right here. Hopefully I won't forget the word through again. And I'm going to change the word vertical to horizontal. So y equals c is a horizontal line passing through the number c on the y-axis. Now, what I'm saying might be exactly the opposite of what you're expecting, because the y-axis, that's vertical, but y equals a number, that's a horizontal line, and I'll show why in a moment. Let me go ahead and I'm going to define x-intercept again. The x-intercept is the point where the graph passes through the x-axis. So
This one does.
Oh, okay. And like we said the last time, if it's passing through the x-axis, it's on the x-axis, then the y value has to be 0. Last time we said every y is 0 on the x-intercept, so the ordered pair is going to look like this. Some number, comma, 0. I'll repeat that for the y-intercept. That's the point where the graph passes through the y-axis. If it's passing through the y-axis, then that means the x value has to be 0. So it's in the form 0, comma, some y value. And I think I've talked long enough. I think we should start doing some problems before y'all decide this is really hard, which it's not. Okay. So let's look at problem number 1. Okay, problem 1.
Wait.
Plus.
Look at the up there.
Maybe X more. Okay. Now this is one of those problems that you can do sort of without writing. You can just read the problem, look at the graph, type in the answer. Let's read what it says. Find the coordinates of the y-intercept and of the x-intercept for the line displayed on the right. So you want to pop it out? Oh, okay.
Maybe I'll pop it out.
There. Okay, so we want the y-axis. First, y-intercept. So where is this red line passing the through the y-axis? Y'all see where it is? Where that cursor is?
What number is that?
1.
Now, if you write 1, they're going to count it wrong. It's got to be an ordered pair.
And it's got to, okay.
So how do we express that ordered pair? That point is an ordered pair.
Inside of parentheses,
Mhm.
0, comma.
Okay, that's right.
Okay, did y'all hear that? Parentheses, 0, comma, 1. You just type that in. Oh, wait, you type it in.
Parentheses, 0.
Now here, each little line is 1 unit, but we got to watch out on some of these graphs. Maybe each little mark is not incremented by 2, 2, 4, 6, 8.
1, 2, 3, 4, 5, 6. Here it's all just by 1 unit. Let's pop it out again for the x-intercept.
Put your cursor where it's crossing the x-axis.
There it is. What number is that on the x-axis? 4. So how would we write that as an ordered pair? You start at the origin and you go 4 to the right,
comma,
0, because you don't want to move up or down. So 4, 0.
Y'all see how we're getting these ordered pairs? Any questions there? Problem 2, it's going to take a little bit of work. I mentioned earlier before class, I decided when I was making this assignment, I didn't feel like doing those graphing tools. I only assigned the old multiple choice problems. Every time I look at this assignment, I wonder, is today the day where they'll do away with the multiple choice and it'll be graphing tools?
I'll take over then, because you know I like this graphic.
Oh, okay. So we have x minus 2y equals 2. And wait, what did the instructions say to do?
Find the intercepts.
Find the intercepts and then graph the line. Now, finding the intercepts, that's what we were doing the last time on the first 2 problems. In order to find the intercepts, you've got to plug a 0 in for y and a 0 for x. 0, 0. So that's just setting it up. Now let's plug in 0 for x and solve for y. So I'm doing this ordered pair right here. Plug a 0 in for x, figure out y. So whatever. 0 minus 2y equals 2. Well, 0 minus 2y is just a negative 2y. What am I going to do now to solve for y? Divide both sides by negative 2, and we get y equals, is that a negative 1? So there's my, which one is this? This is the y-intercept that I found first. Now let's, do this one. Plug 0, oh, I think this one's going to be even easier. Plug a 0 in for y. Oh, this one's y equals 0. If I put a 0 in for y here, I just have x minus 2 times 0 is just 0 equals 2. So is that just turning out to be x equals 2? You'll see how I did that? Put the 0 in for y. So x equals 2. I'm wondering if that makes it better or not. No, it's flickering, so
And
okay. So I just found, what was this point right here? Well, the variable that has a number is 2, is the x variable. That's the x-intercept. Okay.
so let's
So let's look at the multiple choice. Let's see.
I thought it was A, but is it?
Is it A? Oh, no, it isn't. It says negative 2, 0.
Watch those signs. Let's look at C. It's passing through. Oh, I think I better
Blow it up.
blow it up. Okay, so, hey, they're incrementing in units of 2 here. 2, 4, 6, 8, 10. So that would be 2 on the x-axis. Is that what we needed? Yes. And what number do we need on the y-axis? Negative 1. Is that negative 1? It looks like negative 1 to me. So which, this was C?
Just go D. What's wrong with the D?
The y-intercept.
1.
Yeah.
Okay.
Any questions there? Oh, this is a good one.
Okay.
Here, they're not telling you to find the intercepts. They're just saying, graph this line, x equals 3.
And before we do it, let's look back over here at what I have right there, what I wrote. X equals C. Could y'all replace the letter C with the number 3 and reread it, this sentence here? X equals 3 is a vertical line passing through the number 3 on the x-axis. So I'm going to write it out and graph it by hand. Problem number 3, x equals 3. We're told to graph that. One, two, three, 4. 1, 2, 3, 4. I'm just drawing a little graph paper. Okay, so that sentence that I wrote, x equals 3 is a number, is a vertical line passing through this number on that axis. You don't have to try to memorize this. What you need to remember is,
this trick works if you make the same little tick marks the way he does, okay? Drawing the axes and putting those little tick marks for 1, 2, 3, and so forth.
When I see an equation with just one variable, I think, okay, it passes through this axis at this number. Locate this number on the x-axis. So locating the number 3 on the x-axis. 1, 2, 3. And then if you see the little mark there, just extend that mark. Every point on this vertical line has 3 as its x value. Yeah, if we were going to label ordered pairs, this would be the point 3, comma 1, 3, comma 2. This point right here would be 3, comma 0. And we'd have 3, comma negative 1, 3, comma negative 2. But every x value on that line is 3. That's why we call x equals 3 this vertical line here. So you're looking for a graph that's passing through the number 3 on the x-axis.
Hey, I think, well, it's clearly not this one. A is horizontal.
Better blow every one up in that.
There,
No,
that's horizontal. That clearly can't
That's
be.
passing through the y-axis at 3. This one's passing through the x-axis, but at negative 3. That's not right. Is this it? Is it passing through the x-axis at 3?
1, 2, 3. I think so. If you look at D, you see it's another horizontal line.
Passing through y.
So,
Negative.
so it has to be option C. Any questions there?
If you have just one variable, then you need to have it written with that one variable by itself. It needs to be in the form x or y equals a number. What about problem 4?
Plus 5 equals 0.
Number 4?
Mhm.
Y plus 5 equals 0?
Isn't that what it said?
Oh, I don't know. I didn't know you'd already flipped.
Mm-hmm.
When I look at this, here's what I notice. There's only one variable, so it's not a slanted line. Well, if there's only one variable, there's a special way it needs to be written. It needs that variable by itself. So what will I do to get this y by itself? Subtract 5. So we have y equals negative 5. So our line should pass through the y-axis. Passes through this axis at that number. What sort of line passes through the y-axis? A horizontal line.
Show me some other page.
Y equals 5 is a horizontal line passing through the number 5 on the y-axis. So I'll sketch out the graph that you could sort of, since it's multiple choice, you can probably look at the graphs and figure out which one it is.
You need to go lower. Y equals negative 5.
Oh, I was thinking it was positive.
On that.
I had a student once tell me that their teacher in high school told them when they're setting up the graph, they had to have the same number of tick marks on left, right, up, down. And I was like, oh, wow, I never heard that rule. So that's why I'm trying to put 5 on all of those.
Mm-hmm.
That's really not a rule. Okay? Just a teacher's preference, not mine. So passes through the y-axis at -5. So here's -5 on the y-axis. What sort of line would cross through it? Well, horizontal. So A, B, C, or D. Maybe we can.
Let's see. Well, clearly not A, because that's vertical. B,
No,
that's another vertical.
That would be x = 5 there.
Here it's horizontal, but
And so it's passing through the y-axis, so that would be y = 5. And what's this one here? Is that y = -5?
can y'all tell this is the blue line here? It's sort of, everything looks a little pale to me, but yeah, it's at -5, passing through -5 on the y-axis. It has to be response D. Any questions there? Not too bad so far.
So far. Okay, now we're going to discuss something called slope of a line. The slope of a line measures the steepness of the line.
There's something wrong.
Do you think we need to?
No, it's fine.
Oh, okay. Does it just look? Okay. Now, slope is denoted with the lowercase m, not an s, and that's a good thing. I don't like to use s because it
looks like a 5.
Yeah, so lowercase m is what we're going to use to denote slopes.
M like money.
Now there's 3 types of lines. You can have slanted lines, vertical lines, horizontal lines. If a line is slanting upward to the right, then the slope is positive. So I'm writing m is positive for if a line is slanting upward to the right. If a line is slanting downward to the right, does anyone want to just guess what I'm going to say right here? M is negative. Okay? A line that's falling when you look from left to right has negative slope. A line that's rising when you look from left to right has positive slope. A horizontal line has a slope that's 0. If you have a horizontal line, its slope is 0. And vertical lines, the slope is undefined.
It's meaningless to talk about the slope of a vertical line, and we'll see why in a moment.
When a fraction's undefined, we had some stuff undefined. When is a fraction undefined? When there's a 0? Yes. So I'm going to go ahead and make a note of that, and you'll see why I'm mentioning that in a moment. Okay. In general, the slope tells you how much y increases as x increases by 1. So if you increase x by 1, what is that going to do to the y value?
I'd say changes because it may decrease.
I know, but then you have a negative. So it's increasing negatively. Yeah, but okay, you could use the word changes here instead of increase. But since we're talking about positive and negative,
Okay, I see.
but I like your use of the word changes. Now we're going to define slope several ways. We talk about it in words like that. It's the steepness of the line. Another way is the rise over run definition. Slope equals rise over run. And by that, what the heck does that mean? It's the change in y over the change in x. And we'll do an example of this rise over run. It's not as bad as it sounds. And,
Okay. Find the slope of the line shown on the graph, and here it is.
right off. What sort of line do we have? A slanted, vertical, or horizontal line? Slanted. If it had been vertical, then you would have chosen option B and you'd be finished. Show them. Vertical line slope is undefined. And we'll discuss why that is in a moment. But right now, this rise over run. Can y'all see the 2 points that are labeled on there?
Trying to show the y-intercept, that's where it. Are they incrementing in units of 1? Yeah, it looks like it. So what number is that on the y-axis right there? Positive 3. What's this number here on the x-axis?
Positive 1. So it doesn't start at one point and move to the other. It doesn't matter the order in which you go. Let's start with the top point. In words, I want you to tell me how would you go from the top point to the bottom point, first doing the vertical movement. That's what rise over run.
Are you going to go up, or would you have to go down? You're trying to get to the second point. You'd have to go down how many units? 3? So, okay, wait a minute. So, we're going to go down 3. The rise, you're going down 3. Now, let's look at the run, that horizontal change in x. You're positioned right here at the origin. You went down 3 units. What are you going to have to do to get to that actual point?
Move right or left? Right. How many units?
Okay, so we went down 3 and right 1.
Now, instead of using the words up, down, left, right, we're going to use signs. Left and down are negative.
Just like on a number line. Down and left are negative. On a number line, right and up are positive.
Since it was down 3, we'll write negative 3 on top. Right 1. That's a positive 1. And then we can simplify. Negative 3 divided by 1 is negative 3. Now, it doesn't really matter which one you started. Here, on this one that I wrote right here, we started at the top. Started at top point.
Do y'all understand what he means? We started here, and we worked our way to the bottom point.
Well, if we started at the bottom point and worked our way to the top, we better still get the same answer, negative 3.
And notice how this thing is falling from left to right. So we knew it had to be negative. We knew the slope would be negative because we said if a line is falling from left to right, the slope is negative. Sure enough, we got a negative slope. But let's suppose you had decided to start at the bottom point and work your way to the top point. You still better get a slope of -3. Let's see. Okay, we're starting here. We're trying to get to this second point. What are we going to do first? Go up or down? We go up 3. Okay, so he's writing up 3. For his rise, he said up 3. Then what are we going to do? We're right here where my pointer's at, where my cursor is. We're going to have to go left 1.
If that's the way you go, you have a +3 on top because up and right are positive. The negative is on the bottom, but are we still going to get the same answer, -3? Yeah, 3 divided by -1 is still -3. So it doesn't matter where you start at with that rise over run.
But to use rise over run like this, you have to be able to clearly tell what the coordinates are for 2 points. So they have to clearly label 2 points on the graph for you. You can't decide, oh, I'm just going to use this point right there. Well, what are the coordinates?
What are those numbers there?
Where are you starting and where are you trying to go?
Well, type in -3 before we time out.
Okay. Oh, goodness.
Now, wait, nope. Just flip it back over here. I want to do another example.
Mm-hmm.
It's just an example. It says, find the slope. I'm going to draw. Drawing my X and Y axis. I'm just drawing a vertical line right through the number 2. And let me label a couple of points. I'm going to put a dot right here and a dot right there. Let's do this rise over run stuff here on a vertical line. All right, M equals. Well, let's start at the top. Let's start at the top point and go to the bottom. So if we're going to go from here to here, we're first going to move down how many units? Is that down 3 based on my graph? Can y'all tell? And then, okay, I'm going from here to here. So I'll go down 3, but wait a minute. What about left, right? Am I going to move left to right any to get to this point? No. So that's going to have a 0 down there in the bottom of the fraction. And what do we know about denominator of 0 on a fraction? Undefined.
Mm-hmm. Right there.
Yeah. In general, for every vertical line, the slope is undefined. Okay? And the reason it's undefined is because you're moving up or down, but you're moving over 0. Okay? And you can't have if the bottom of a fraction is 0, then it's undefined. So this is undefined. And maybe some of your number 5s will wind up like that. Probably not. But I wanted you to see that, try to justify why we're saying it's undefined. Now, let me draw a horizontal line.
Remember, he said that the slope of a horizontal line was 0. Let's justify why that's the case.
2, 3. Ooh, okay. Okay, I'm going to draw a horizontal line through 2. I think just. And let's label a couple of points. There. Okay. If we do rise over run on this horizontal line, where's the 0 going to appear in the fraction? On top. If you started at this point and wanted to move to this point, you don't go up or down. Okay, if you went up or down, you're not going to get to that point. So on this one, the 0 is on top, and then let's see, so you move up or down 0, and then what? Right, ooh, can y'all tell? It's supposed to be right 3. So it would be 0 over 3, which is 0. If 0's on top, that's okay. It's defined in 0. If 0's on the bottom, that's undefined. Okay? So for any horizontal line, you know it's a horizontal line, its slope is going to be 0. If you know it's a vertical line, its slope is going to be undefined. So we've defined slope as
geometrically. We've defined it geometrically and graphically.
Now we have something called the slope formula. Slope formula. If you have 2 ordered pairs, you were given 2 ordered pairs. This is x subscript 1, y subscript 1. And since I need 2 ordered pairs, what am I going to do? How am I going to denote my second one? We did this last time with distance and midpoint. We would just say x subscript 2, y subscript 2. So this just means the first ordered pair and the second ordered pair. And here, if someone said state the slope formula, here's what they're expecting you to say. To get the rise part, go y2 minus y1. Second y minus first y over second x minus first x. The y2 minus y1 is giving you the rise. The x2 minus x1 is giving you the run. Sometimes students say, oh, wow, why do we need to know a formula when it's easy to just count like this? Yeah, but let's suppose you didn't have any nice points. Suppose your ordered pairs were 1/3, comma,
Negative
200.
1/7. Oh, okay.
And then the other ordered pair was 7, comma 50. You don't want to have to be counting all those little squares. This counting rise over run really only works if you have a nice graph labeled.
Like we did here on number 5. The graph and the points clearly labeled. But suppose you had this.
Well, if you want to plot those 2 points and then count them rise over run, that's fine. The only problem with that is, suppose that 7, comma 3 were 70, comma 30. Do you really want to be counting those rise over run then? And so, on problem number 6, let me write it down. We're finding the slope, and here are the ordered pairs. 7, comma 3, and 9, comma 8. Well, I'm going to label each ordered pair just like we did with distance and midpoint.
Wait.
Oh, wow, this is bad. You know what? I'm going to move to a new
Another.
sheet of paper because already this 2 here.
It looks like you're squaring an ordered
looks like some
pair.
sort of expo.
I was wondering if you were
So,
maybe
yeah.
trying to engage in stuff. Yeah.
Okay.
I was wondering if you'd find a new ordered pair operation.
Yeah, whatever.
Squaring ordered pairs.
I don't know.
Oh, I don't remember what it was. 7-3, 7-3,
7-3
and 9-8.
and 9-8. Okay. So I'm going to first of all label each ordered pair. First X, first Y, second X, second Y. Make sure you're labeling them X, Y, X, Y. A common mistake. People will go X1, X2. No, no, no. Now let's state the slope formula. Second Y minus first Y over second X minus first X. So let's start plugging in. You caught up?
How's it going in the peanut gallery over there? The roles have reversed for today, haven't they?
Y2 minus Y1. So I'll put 8 minus 3. And what about X2 minus X4? Well, 9 minus 7. So we plotted those 2 points. We would be going up 5 and right 2 to go from one point to the next. Can I reduce 5 over 2? No, we'll just leave it as 5 over 2. Type it in. Let's see. Hopefully we have one here with more negatives. Well, I guess
With at least, I don't know.
no. Okay. Next.
Don't worry, when they do it, it'll give them plenty of negatives, I guess. They're
Hopefully
just being
they'll-
nice to us.
Same type of problem. 4, 0, 5, 5. I'll do exactly what I did right there on number 6. I'll call this one first X, first Y, second X, second Y, second Y minus first Y over second X minus first X. If you have graph paper and you just want to plot the points and count, that's fine. It's sort of unfortunate that this is one of those times when they should give you some points, some really big points, order pairs. 41, 107. You wouldn't want to plot those on the graph. So let's see, what am I going to write? For Y2, that's 5. Y1 is 0. So I'm going Y2 minus Y1, and then X2 minus X1. So what are we going to have here as our slope? 5 minus 0 is 5. 5 minus 4 is 1. How do y'all think I'm going to write that? Just a 5. 5 over 1, 5 divided by 1 is 5.
And we can type an integer, 5.
What about problem number
8.
8? Oh, okay. Well, we have a negative. It's negative 4, comma, 8, and 3, 2.
Oh, by the way, looking at 6 and 7, if you were to draw the graph, do you expect the graph to be rising from left to right or falling from left to right? Notice the slopes are positive, so with the graph, do you expect those lines to be rising from left to right or falling? If the slope is positive, you expect it to rise when you move from left to right.
Okay, so here are my ordered pairs. See that we're just saying X and Y. First X, first Y, second X, second Y. That's what those subscripts are doing. Second Y minus first Y over second X minus first X. Plug in. Y2.
Have them tell us. What's he going to write right here? 2, okay. What's going to go here? 8, okay. Here? 3, and? Okay, so y'all weren't dozing off. Okay.
They don't doze off, and I'm the one writing. They doze off, and you are. 2 minus 8. What's that going to be on top? Negative 6. Now, here's the tricky part. Watch out. Why am I saying this is tricky? We have the red minus is from the formula. And then the purple minus, you may not be able to tell that's purple, but it is just negative 4. Minus a negative, what am I about to do? Change that minus a negative to a plus. So what number do we have on the bottom? 7, okay? See how I'm getting the 7? 3 minus a negative 4 is 3 plus 4. 3 plus 4. So can I reduce 6 over 7? No. So negative 6 over 7.
6 over 7.
Hey, is this graph going to be rising or falling?
If you were to draw the graph, would it be going up or would it be going down? Down. It'd be falling from left to right because of the negative slope.
Now, I'm thinking I'm using too much red.
I think it's time for you to talk about slope intercepts.
Did you want to?
I'll take over.
Okay. Yeah, I'm expecting a phone call from a doctor, so
After 3 o'clock.
Is it a pie? Okay. Slope intercept. Slope intercept form of a graph. Slope intercept form of a line, I'll say. This slope-intercept form of a line is considered one of the most famous algebraic formulas. People seem to remember it, so we'll see what you, if you all have seen this before and if you remember it. Let's assume a line with slope m. And you'll notice I'll make a cursive M like money. It has 3 little humps in it. So you can tell that's an M, not an N like Nancy. Tony makes only 2 humps on his M. For clarity, I make 3. Let's assume a line with slope M passes through the point x1, comma, y1, the slope-intercept form of a line is y equals mx. You know something? I was getting ahead of myself. Instead of passing through the point, that's the general point x1, y1, let's say passes through the x-intercept 0b. We don't have just a generic point x1, y1. We know the y-intercept. It's at point 0b. You go left, right, 0, and up or down, whatever b is. Graphically, we have a line that's passing through, it's passing through B on the y-axis. And for the sake of this example, I'll just have it slanting like that. There. And that line has slope m. The equation for that line is y equals mx plus b. That b is the y-coordinate of the x-intercept. I've written that backwards, haven't I? What did I do wrong here for the x-intercept? It should be a y-intercept, shouldn't it? I'm just really messing up today. Ugh. My mind's not here. My mind's on that. I nearly said that doctor's call that we're expecting. So the slope is denoted with the lowercase letter m, and the y-intercept, not the x-intercept, the y-intercept is the ordered pair 0b. And to write equations of lines, the only thing that I'm going to use will be the slope-intercept form of a line. There's two other forms that are frequently presented in algebra books. The point-slope form of a line, and there's another one, the two-point form of a line. And all of those things are just hoaxes. You don't need those different formulas. All you need to know to write the equation of a line is the slope-intercept form. Now, if they give you the y-intercept, then great. That makes it especially easy. For example, if they told you that the slope of the line was a positive 1/3, and that the line passes through the ordered pair 0, 7. To write an equation for this line, all you have is y equals, we know m is 1/3, and that b, the b value, is the number where the graph passes through. I nearly said it again. It's the number where the graph passes through the y-axis, not the x-axis. I don't know why I'm hung up on the x-axis today. Let's do the next homework problem. Oh, okay. Okay, number 9.
Some problems, you gotta write them down and then scribble, scribble, scribble to get an answer. I'm not sure this is one of those. But let's see.
This is a nice one, a nice fast one. Find the slope and the y-intercept to the line. If an equation is solved for y, when it's solved for y, that's when you have the slope-intercept form of a line. Y equals mx plus b. The number in front of x, if it's solved for y, the number in front of x is automatically the slope. So the slope is negative 7/8. They want the y-intercept, the line will pass through the y-axis at the number 4. But they want that written as an ordered pair. So the y-intercept is, the x-coordinate is 0, the y-coordinate is 4. So the slope is negative 7/8. The y-intercept is 0, 4. And I'll warn you again, for the intercepts, they want them written as ordered pairs.
So negative 7/8. And look at this
Oh,
one.
wow.
For the first one, they do this.
I was about to say, oh,
They
they're
don't-
really nice.
Yeah, they are. See, all you have to do is type in the 4, but on the next one, maybe it doesn't say parentheses 0, comma. You have to
bet it
type it
doesn't.
in. Any questions there? The slope y-intercept. Let's see. Okay.
Oh, the same. You know something? I don't think I have to write anything down here. The equation's already solved for y. It's in slope-intercept form. So when you look at that equation, and they want to know what the slope is, what would you tell
3/4.
them? 3/4?
That is right.
If you were to draw this graph, would you expect it to be rising from left to right or falling from left to right? Rising because the slope is positive. Now
Okay.
the
Here's the tricky part. I don't just type 6. I wonder what would happen if I did. Is it going to tell me, hey, write it as an ordered pair? Okay. Your answer must be in the form of an ordered pair. Make sure you've enclosed it in parentheses and done more than just that. What should I put here?
what's the x coordinate? 0.
Okay.
You don't want to move left or right.
0, comma, 6, close parentheses. Now, they can't all be this easy. Any questions? Y'all caught up?
Okay. Here's number 11. Here we need to do a little writing. Not much though.
Same instructions. Find the slope and the y-intercept, except look at the equation. It's not solved for y.
This is
That's
not in slope-intercept form. This is in standard form, that ax plus by equals c, but that's not the form we need. We need this in slope-intercept form, which means we need to solve for y. It's pretty easy to get that y by itself. What do we need to do? Okay, so we'll move that negative 2x over. That's going to give us y equals, the negative 2x is going to become a 2x, and we still have that minus 7. Y equals mx plus b. You say, well, that's not a plus. Sure it is. It's a plus and negative 7. So m is 2. What's the y-intercept? We're going to have to write it as an ordered pair. I heard 0, and the y-coordinate is negative 7. Just like right here, that was a plus 4, so we had a y-intercept of 0, comma, positive 4.
Is it clear why we move that 2x around? How does this problem differ from the other ones?
Well, it wasn't solved for y. To be able to, in order for the coefficient of x to be the slope of the line, the equation has to be solved for y. The constant term is the y-coordinate of the y-intercept.
Interestingly enough, during our lifetime, the definition of y-intercept changed.
And x-intercept. It used to be, if you go back and you look at some
Old books.
from the 70s and 80s, let's say.
Well,
They
you know-
defined intercepts as the number where it passed through the X or Y axis. So 40 years ago, if we'd been asked to find or to state the Y-intercept, we would have just said 4 or -7. But now it's standard practice to define them as ordered pairs.
My graduate advisor and dear friend, when we first saw ordered pairs written, intercepts written as ordered pairs, I remember her saying, that is so stupid. So what are we going to tell them for slope-intercept form? That B is the y-coordinate of the y-intercept? And yeah, that's what we got to say. Back in the olden days, you would say B is the y-intercept. There was none of this comma, zero, parentheses, zero stuff. You just wrote 7. But, let me type these in. 2 and 0, -7. Okay. Oh, no.
Where is
it?
There, right?
The slope is 2. See, back in the olden days, you would have just typed -7. But that was 40 years ago. I still can't believe it's been so long. Uh-oh, I did something wrong. What did I do wrong?
I don't know. You put a period after the 0.
Oh, my gosh. Oh, wow. Y'all have those sharp eyes. I don't think I would have ever figured it out. What I done wrong.
I'm here looking.
Okay. Oh, wow.
The vision's better than ours, too.
Mm-hmm. Okay, so let's
Number
try
12.
another one. Oh,
Let me write it down.
same instructions. Find the slope and the y-intercept.
25x plus 5y equals 15.
Oops, what did I do? I thought
I remember back in high school algebra, there were little formulas. You had a separate little formula for everything. They had a separate little formula. Okay, this is a standard form for the equation of a line, and we had a little standard little formula to determine the slope there. It was -a over b.
negative b over a. Right.
No, -a over b.
Yeah, you're right. Yes, you're right.
I remember thinking, it just seemed ridiculous to have a different formula to memorize to find the slope of a line when it's in standard form. We can just write it in slope-intercept form, and whatever number is on the coefficient, is
In front of that.
is in front of the x, has to be the slope. We want to solve for y. There's only one sensible first step. What is it?
Move that 25 over. Good.
So we have a positive 5y equals a negative 25x plus 15. And that's right. We're going to divide by 5. Notice we're dividing each term by 5 to give us y equals here negative 5x plus here.
15 divided by 4.
So the slope is -5, I agree. What about the y-intercept? So 0, 3.
So -5 and 0, 3. Let me see if I can punch that in without making a mistake. -5 and 0, comma, 3. Okay, good. Any questions on this one?
Okay. Now, here they've been giving us the equations of the line. Well, where did they come up with those equations they were giving us? I suppose a sensible question is, how do you write an equation? Where are they coming up with these equations? To write an equation of a line, you need to know a slope, and you need to know a point on it, preferably the y-intercept. Preferably, they'll tell you the y-intercept, but in many cases they won't, and we'll have a neat little trick to figure out the y-intercept. But you got to know something about the slope. If you don't know the slope, they're going to have to give you information to help you determine the slope. But either way, let's look at number 13. Find an equation of the line having the given slope and containing the given point. This is what I was wanting to jump to. I was thinking of point slope, and so, oh goodness. So, number 13. I'm right, we don't even state the point slope formula anymore. We do everything with slope-intercept form. M equals 8. They tell us the slope of the line, and they tell us that the line is passing through the point 7, 1.
Is this the y-intercept that it gave us? No.
7, 1 is not the y-intercept. We know the slope at least. We know the slope is 8. So, in general, we have y equals mx plus b. Is this pen dark enough?
Oh, I just works fine for me. I don't know what's wrong with you.
So we have y equals, this was even dark. Is that visible, the y? It's pink, isn't it?
Mm-hmm.
Okay, so, hey, it matches my shirt. Someone gave me this shirt and I thought I needed to wear it.
Yeah.
So we know the m is 8, so 8x plus, we don't know b. They didn't give us the y-intercept. They gave us just an arbitrary ordered pair. They gave us an arbitrary xy. Does that give you a hint of what we're going to have to do?
They didn't tell you.
They didn't tell you the b, but they told us x and y. They gave us an x and a y.
What's he hinting at poorly that we're going to do with that 7 and 1?
We're going to plug
1
in for y. Oh.
Okay. To me, that pink is now not looking right.
We don't know b. We have that plus b stuck on there. Y became 1. X became 7. They didn't give us the y-intercept, but they gave us an x and a y that we can plug in. 8 times 7, that's 56. So we have 1 equals 56 plus b. I think we can solve for b now. What is b going to equal? I couldn't hear you. What are we going to do to get that b by itself? Okay, so we'll make a minus 56 and minus 56. So that's 1 minus 56 is negative 55 equals b.
But wait, no. What's going to be our final answer?
The final answer, they want an equation.
Let's look at this. It says, find an equation, and then look right here. The equation of the line and slope intercept form is y equals, here's where you type in the mx plus b.
So y equals, we said it's an 8x, and that plus b, in place of that plus b, what do I have? Minus 55. Good. Oh. Any questions there? You've got to know the slope of a line, or else they have to give you information so that you can determine the slope of the line. They didn't give us the intercept, the y-intercept. They gave us just an arbitrary xy. We were able to plug in that xy to find b. So now if I asked you, where does the graph pass through the y-axis? What number would you say? 0, negative 55.
Let me type that in. 8x minus 55. 8x minus 55.
Will you do me a favor and view an example? I'm wondering if they do it like this, or do they use the point slope form?
Oh, there's the point slope form.
Yeah, it's just a hoax. It's just a hoax that's perpetuated on the American public. We don't need that to write an equation of a line. And they want the answer, the final answer in slope-intercept form anyway. So why don't you just use the slope-intercept
Oh
form?
my gosh, I love it.
Yeah, that is really clear there.
This right here tells you everything you need to know. Write it down. I'm joking about that. Why are they doing that?
Let's do number 14.
Oh, there. But
Oh, goodness.
this is one of those times when we're not doing it the way view an example does.
That's a whole other formula that I'm not even writing down. Although it's pretty easy to derive that point slope formula. Students just see it as another formula. So if you can do it, the fewer formulas, I think the better.
Mm-hmm.
At least 30-something years of experience have shown that. So we want to find the equation in slope-intercept form. We want it in the form y equals mx plus b.
We could actually get started. What's the first in this box? What am I going to type first? Oh, wait. M. It's y equals mx. So 5, 6x. Okay? 5 over 6, right arrow, x. But I'm not finished. We now need to know that b part. So to do that, let me show us.
Y'all agree this isn't the y-intercept. 3, negative 2 would not be on the y-axis. So we're going to pull that same trick we had a moment ago. We know the m value is 5 over 6.
You know what?
No.
Why don't you multiply straight through by 6 and get rid of the fraction? You're about to have to plug in a 3 for x and a negative 2 for y. Most people find it easier getting rid of the fraction first. That's what I did last semester.
I think that's a good idea.
What would I need to multiply straight through by to get this denominator to cancel? 6. Let's do that.
Realize that there's one term on the left, and how many terms on the right?
1,
2. So we're going to have to multiply 3 times. We're going to have to multiply by 6 here, 6 here, and that b is going to get multiplied by 6 also. So we're multiplying by 6 times 6 over 1 and multiply by 6.
And you say, well, why is he doing that? It's going to make it easier when you plug in the x and y.
So we have 6. I'm going to start plugging in the y.
Oh, what a
well, okay, you're right.
Neat.
Let's write it neater. When we take 6 over 1 times 5 over 6, what's it ought to cancel in this product here? We have 6 over 1 times 5 over 6. The 6's cancel, leaving us with just a 5x. And we still have that 6b.
I think most students find it easier plugging into this. Plug the 3 in for x and the negative 2 for y. It works easier, I think.
Okay, let's see. We have 6. We're going to replace y with the y value they gave us, negative 2, equals 5. What are we going to replace that x with? 3. And we still have that plus 6b, 6 times negative
Be careful. I just blinked my eyes and it looked like 66, but it isn't 66.
2. They saw the period earlier, Tony.
I know.
Their vision's a lot better than
Okay.
ours. So that's a negative 12 equals, what have we got here? 15 plus 6b. We're trying to find b. Remember what we're looking for. We want the equation of the line in y equals mx plus b form. We're trying to solve for b. There's only one sensible next step to get b by itself. What will I do? Subtract the 15, minus 15, minus 15. That gives me a negative 27 equals, what have we got over here? 6b. Oh, we're still ready. We still don't have b by itself. What do I need to do? Divide by 6. And that's going to give me b equals, negative divided by positive will be negative 27 over 6. Does 6 divide evenly into 27? No, but we can cancel what number above and below? What number divides evenly into 27
And
and 6? 3. 27 divided by 3 is 9. 6 divided by 3 is 2. So my final answer, the thing I'm going to type in, I'll use this color. Y equals 5, 6x.
okay, you're replacing the m with 5 over 6.
And you've already typed in the 5, 6x
Uh-huh.
for us. What am I going to replace the plus b with? So minus 9 over 2. For my final answer.
5, 6x minus 9 over 2.
You know, I like getting rid of the fraction right here.
Mm-hmm.
That made this cleaner. At the end, we picked up a fraction for b, but that was easier than having to multiply and then add fractions, getting a common denominator along
Sometimes
the way.
you might not understand why we're doing what we did, but here, hopefully you see why we multiplied through by 6. It's for this step here, when we plug in the 3 for x and the negative 2 for y. And so I think it works out easier like that. So 5 over 6x minus 9 over 2. Okay, I've already done the 5 over 6x. I knew that. Minus 9 over 2.
Where does the graph pass through the y-axis on number 14? That problem we just did. Where would the graph pass through the y-axis? Okay, 0, comma, negative 9 over 2.
And I'm going to go ahead and convert that 9 over 2 to 4.5. So it's at negative 4.5. We can't
On the
type that
y-axis.
in. I don't want that. But, if you were actually going to plot it, you'd have to think, 4.5. Okay, yeah. Any questions before we do the last problem? And this is one of those times when it's the last problem, so it has to be the hardest. Well, we know how to write the equation of a line if we were given the slope and 1 point. Look at number 15. You got to be able to distinguish, how does this problem differ from the previous one? How does 15 differ from 14? And the most basic problem-solving strategy is, when you confront it with a new problem, can you make it look like the other one? What's different here? Are we given m equals? No. Is there some way maybe we could find m to make it look like problem 14?
Well, obviously, we're going to have to use the 2-point formula
y minus
of a line.
y1 equals y2 minus y1 over x2 minus x1 times x minus x.
Yeah.
No, actually,
There's a separate formula. It's crazy, the craziness that we did in high school algebra classes. Surely they didn't do that. Surely.
well,
Okay.
they're going
Okay.
the way we did.
Okay. But they still use that point slope form.
Yeah, I
which is
know.
so unnecessary.
So he's talking so much, what do y'all think we're going to have to do first? We're trying to hint at it. We know what to do or how to do it if you have M and a point.
But they didn't give us M here. They gave us two different points.
So
what can we do?
Did we do something today with 2 points, find the slope?
Let's see, where was that?
It was when I was writing.
Oh, here it is. We had several problems where we were using the slope formula to find the slope. So we have that additional step, we have to do one extra step. We're going to have to find the slope first. We want our equation in the form y equals mx plus b. So the first thing we're going to do, we have to find m. Find the slope m. We know m is equal to y2 minus y1 all over x2 minus x1. And I think we should label this thing here. Here's my first x, my first y, my second x, and my second y.
Is it clear why we're doing this now? We're trying to find the slope to make it look more like number 14. If you're going to write the equation of a line, you've got to know that slope. It doesn't matter what you do. You've got to know the slope.
Or you got to know it doesn't exist. If the slope doesn't exist, it's a vertical line.
Mm-hmm.
Otherwise, it's a number, and you have to know that slope.
Talk us through. What are we going to put here? 6 minus 5 is what goes on top.
Here,
3 minus 1.
3 minus 1. And that's going to give us, oh, this is a pretty nice slope as these things go. 1/2.
Mm-hmm.
So we have a slope of 1/2. But this isn't like problem 8 where we just stopped. We found the slope. That's all they wanted. Let's see. Yeah, we're not through yet, but we do know the number that's going to go in front of the x value. We know that our equation is going to look like y equals 1/2 x plus b.
Why don't we go ahead and restate number 15 to look like number 14? On problem 14, they told you m equals, and they gave you one ordered pair. Well, here we have 2 ordered pairs. You just choose which one you want to work with.
You only need one ordered pair when you're solving for b. Remember over here, you didn't use 2 ordered pairs to find the b.
Mm-hmm.
So which ordered pair do you like better? 1, 5 or 3, 6? It makes no difference. We'll still get the same answer at the end.
3, 6? Okay.
3, 6? Okay, so let's use 3, 6.
Here, if there'd been one ordered pair with a lot of negatives, I think I would have said, choose the one that doesn't have the negatives, but none of them have any negatives, so okay.
So our final answer, our final answer is going to be y equals 1/2 x, and then plus or minus a number. What we're trying to find is that b value there. So we're going to plug in 3 for x and 6 for y.
Should we multiply through by some?
What do you think we could do to not have the fractions here, the fraction here? Multiply 3 by 2, that's my advice to you. Do that, just like we multiplied by 6 here. So I'm going to multiply by 2. Oh, by the way, how many terms do you have? How many terms do we have?
1, 2, 3.
Okay. There it is. We're going to multiply 3 by 2. We're trying to cancel that 1/2, that denominator. Multiply by 2, multiply by 2, multiply by 2. So 2 times y is equal to, what's going to happen here?
The twos are going to cancel out.
The 2's are going to cancel out, just leaving us 1x plus 2b.
Label this X, Y. Plug in.
So now we're going to plug in our xy, our 3, 6. We could have used 1, 5. Either way, we get the same final answer. We're going to plug in 6 for y. We'll plug in 6 for y. And what are we going to put here in place of x? 3, I agree. So we have 12 equals 3 plus 2b. So only one sensible next step. To get b by itself, we will subtract 3. 12 minus 3 is 9 equals 2b. Divide by 2 to give b equals 9 over 2. I should have written smaller. So we know we have a 1/2 x here. What are we going to put in place of that plus b? A plus 9 over 2. I agree. So here's the equation we're trying to write. Y equals 1/2 x plus 9 over 2. Hold on.
Oh, yeah, do a physical zone. Sort of late in the class.
Yeah, there it is. Our final answer. So if we looked at the graph of this line, where would it be passing through the y-axis? Just give me the number. 9 over 2, 4.5.
Isn't that, wait, is that what the other one was?
No, the other one's negative.
Negative. Oh, okay.
That's just a coincidence that 14 and 15 both had 9 halves there.
Y equals 1 over 2. Do not do that. If I do that, is it about to count it wrong?
Mm-hmm.
Yeah, the X doesn't go in the bottom. I just go right arrow, then I put my X plus 9/2. Okay. Any questions here? Well,
Any questions of what we're doing the rest of the week now? Wednesday is for in-class testing on quiz 1. If you're taking the quiz here in class, bring your device. Remember, older Chromebooks and iPads do not run that.
any sort of tablet.
Any sort of tablet. You're right. Does not. They do not run that.
But I'm sure they're working on it.
Mm-hmm.
Okay.
Actually, it's already set up like that. There's a way, but well, cut that off and I'll tell you.
Okay. So.
Any questions before we stop recording? Okay.